All right, this is going to be a video on geometric mean. First, we're going to talk about the right triangle similarity theorem. We're going to recall that all triangles that are similar have the same shape, but they are different sizes. So we've got these three triangles here showing you three similar triangles. The theorem states that if we have a right triangle, we draw an altitude, segment AD right here, to the hypotenuse from that right angle. It's going to form two triangles that are similar to each other as well as the original triangle. So I'm going to go ahead and put in some colors to show these different triangles. So here I've also finished and filled in the similarity statements. Please pause and color these in. Triangle ABC, the original, is going to be similar to triangle DBA. Now the order of the letters has to go in this order because as we talked about with similar triangles, we do have corresponding parts together. If you are watching this video and you're not a student of mine and haven't covered that, you can search my channel for similar triangles and I explain it a lot. I explain it slower and I actually explain it here. I'm just going to go ahead and say, all right, triangle ABC is also going to be similar to triangle DAC. Okay, again, corresponding parts together. And then also, not only are both of these similar to the original, but they will be similar to each other. So we're going to identify and draw the similar triangle, right triangles in the diagram, just like up here, but we're going to go ahead and draw them. So we're going to go ahead with three different colors. I'm going to draw these triangles out. So when we draw these all separately, we didn't separate it like it did at the beginning, we just split them apart. So we need to realize where these right angles are, knowing that G on the original, J on the medium size, and J on the small triangle all correspond. G is where the original's right angle was. J is where the medium triangle's right angle was. And then over here we have another right angle, J, being the right angle for the smaller triangle also. Want to know which line represents the altitude. The altitude is that segment that splits the two smaller triangles. So this would be segment GJ. And now with these triangles, we're going to go ahead and complete the similarity statement. Here we have, if I drew in my purple color, triangle GFH will be similar to triangle JGH. Oops, wrong color. And will also be similar to triangle JFG. Drawing them out like this will also help us see our corresponding parts. So next we're going to talk about, the title says geometric mean. So let's look at what does geometric mean mean. Okay? Your geometric mean is going to be it's going to be two positive numbers, A and B, the positive number of that, all this stuff. Let's look at this in layman's terms here. We're going to be setting up the bottom left and top right will always be the same thing here, okay? And we're going to be doing cross products and winding up where it's going to come out to x squared is equal to A times B. Being that said here, again, knowing we've got x's, okay? Same thing in the bottom left, top right. I'll be saying that for this entire part of the unit. Bottom left, top right, same thing. When we cross multiply this, we get x times x is x squared. We cross multiply this, we're going to get A times B. What the shortcut is that x is going to be equal to the square root of AB because we have to take the square root of both sides to get rid of that radical. Okay, and it says it down here again. Geometric mean of A and B is given as x equals square root of A and B. All right, let's go ahead and practice. We are going to go ahead and find the geometric mean of 24 and 48. The geometric mean is represented by that letter x. Okay, we're going to leave this in simplest radical form. If you are not one of my school's students, you can also look up simplifying radicals on my videos to figure out exactly what we're doing here. So with geometric mean, you're going to have a proportion. So here's your proportional setup. We're going to plug in answers here, or we're going to plug in things here. That geometric mean being x is going to go in the bottom left, top right. So here's x and here's x. The 24 and 48 doesn't matter which one goes in which of the other two spots. Okay, it does not matter. We will just be multiplying them. Now we'll go ahead and do our cross product here, getting that x squared. And then when we multiply the 24 times 48, we're going to get 1,152. Now we need to take the square root to get rid of the exponent, and that's what's up here. We take the square root of the product right here. And we'll go ahead and go to the side. If you've never watched any of my videos, when I simplify fractions, I do a division tower with prime numbers so that my pairs of numbers are always together. And what that looks like here is if I take 1,152, I'm going to start dividing and building a tower. And I'm actually going to move over here because I already know how big this tower is going to get. So I'm going to move over here, 1,152. I'm going to divide by the smallest prime number possible, 2, until I can't divide by 2 anymore, then move up to the next smallest, and I go in order. So when we divide this by 2, we're going to get 576. Keep dividing by that 2 until we can't anymore. 288. Divide by 2, we get 144. Divide by 2, we get 72. And a very, very tall tower here. Divide by 2, I get 36. Divide by 2, I get 18. Divide by 2, I get 9. Now I can no longer divide by 2. I'm going to move up to the next smallest prime number of 3. I can divide by that, and I get 3. I stop when I have a prime number at the very, very top. So now we'll go ahead and take the radical house, and I'm going to see what partners do I have here. I've got a pair of 2s right here. I'm going to go outside. Again, in my Simplifying Radicals video, I explain exactly the storyline behind this. Here's a pair of 2s. It's going to go outside. We have another pair of 2s. Now, the other 2 doesn't have a buddy, but I do have a pair of 3s. Everything outside gets multiplied. Anything without a buddy is going to go on the inside. I'm going to circle that. So that leftover 2 goes inside by itself. We multiply everything on the outside, 3 times 2 times 2 times 2. We're going to end up with 24, and then we leave it as the square root of 2. I encourage you to pause it and try this one on your own. I know I've got several students who will do that. Okay, we can follow the exact same lead that we did here. Here's our proportional setup. 15 over x equals x over 20. Bottom left, top right. Geometric mean, we have the x. When we cross multiply, there is our x squared. And then we have 15 times 20 giving us 300. Take the square root so that we can cancel. And then we're going to take this 300. Let's go ahead and build our tower. Dividing by 2, we get 150. Dividing by 2, we get 75. Can't divide by 2 anymore. Can we divide by 3? Yes, we can. And we're going to get 25. Okay, I can't divide by 2. I also cannot divide by 3. 25 is not prime. The next highest prime number is 5, and that's going to give us 5. So now we are left with a prime number at the top. So let's go ahead and look at our radical house. We have a pair of 2s here that go outside the house. The 3 does not have a buddy, so he's going to go inside the house. And I have a pair of 5s going outside the house. We multiply everything outside to get us 10, square root of 3. Now, when we look at a geometric mean with our similar triangles, we first have the altitude theorem. Okay, the altitude theorem, what I look at is, there's a little shortcut here, is altitude is the square root of part times part. I like to just do the proportion and set it this way. We use the term PAP, P-A-A-P. This is part 1 over altitude, altitude over part 2. Notice that diagonally from bottom left, top right, just like with geometric mean, the exact same thing. The other 2 are not the same. One's a part 1 and one's a part 2. So let's look at what we're talking about here. Part 1 could be right here. Okay, so there's part 1. Your altitude, the bottom left and top right, the same thing is going to be right here, drawn inside. And then your part 2 will be this other part. The parts are part of the hypotenuse, okay? And whenever we separate it out, we see part 1 times altitude, altitude times part 2. And the way we look at this is as you're setting it up, you're going to, and other teachers call it the heartbeat, because whenever you start over here at the B, you're going to go part 1, altitude, back down, altitude to part 2. Me, I just look at it as you go over, up, down, over. You never pick, you could trace the entire thing without picking your pencil up. Bam, 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 bam. You're not going here, you're not going like here and then up here, and then you're just straight up, boop, boop, and that's why they call it the heartbeat. So let's take a look at the first example here. We're going to find the geometric mean, we're going to use geometric mean to find the value of of x. So we're going to have a proportion, and whenever you notice yourself using altitude, okay, we'll see this on the next one, you know that you're going to be using PAP, P-A-A-P. So this is going to be your part 1 over altitude is equal to altitude over part 2. All right, setting up our proportion. Part 1, 6 over the altitude, x, is equal to x, bottom left, top right, always the same, over the part 2 of 3. Now we can do our cross multiplying. We get x squared equal to 6 times 3 is 18. Want to make sure that we simplify the 18. We take 18 for our, I'm doing the division tower, divide by 2, we get 9. The next prime number is 3. Let's see what color I didn't use. I've got a pair of 3s that will go outside the radical house, leaving that lonely 2 inside. And we only had one pair, so we don't need to do any multiplying like we did earlier. And your answer will be 3 square root of 2. Now, when you're looking at part 1 and part 2, it doesn't matter whether the larger one or the smaller one is part 1 and part 2, does not matter. Okay, that just means we're going to be switching these, and it won't make a difference. We just make sure bottom left, top right is our altitude. The other thing, other than PAP, is going to be your leg theorem, and we call this HELP. Okay, the HELP is going to be, you're going to have your hypotenuse over leg 1 equals leg 1 over part 1. Again, bottom left, top right, the exact same. Now, there are 2 of them because it depends on which leg you're using. You have to use the part that connects to it. Okay, so here we can look at, and again, you won't be picking your pencil up if you go through this. Whenever you're tracing it, we're going to go hypotenuse. Okay, notice where I'm going, hypotenuse over leg 1. See how those are connected. Bam, bam. And then you're going to repeat, go back down that leg 1, and then part 1. So you're looking at the part of the hypotenuse that connects with that same leg. You can't go hypotenuse, leg 1, pick up your pencil, come over here to part. No, they have to connect. Starting at C, over, up, down, just over to the altitude. And that's what that looks like. And then, of course, if you go the other direction, hypotenuse, leg, this part. You can work that out as well. So here we'll find the value of y using this method. Here we're noticing we're not using the altitude, so there's an A in PAP, so we can't use PAP. We have to use HELP. So setting the HELP up, we will do hypotenuse over, and I'm just going to call it L1. Okay, we don't know whether it's L1 or L2, but then making sure that we have part 1. We have those little suffixes of the 1s all matching. So to set up our proportion now, we're going to look at the hypotenuse. Careful. You have to add, the hypotenuse is going to be 7. So we're going to from hypotenuse, connecting to the leg, y, bottom left, top right, always the same. So go hypotenuse, leg, back down the leg, and then only doing the part that's connected right here. All right, let's go ahead and do our cross product. Y squared equals 14. We take the square root. We want to make sure that we go simplify. What we're going to notice, we divide by 2, we're going to get 7. What ends up happening in this case, we have no pairs. So what that means is that this radical is already simplified. So go ahead and write that in so we see that this, they are both prime numbers, no partners, so it's already simplified. We leave it as y equals the square root of 14. All right, now we're going to find the value of x. This one's going to be a little weird, okay, because of our hypotenuse when we add. First, we need to see that we're not using the altitude, so we're not using a, so we have to use help. Remembering that help is your hypotenuse. Go ahead and I'll do both at the same time, filling it in. Now, I'm going the direction of the leg that I've got information of. You need to see here, the hypotenuse is not just adding 2 numbers. Your hypotenuse is going to be x plus 9. So we got the hypotenuse leg of 15. Repeat the leg, and then only the part that is connected, the part of the hypotenuse that's connected to that same leg, 9. Now this one is also different because in all the other geometric mean problems we have done, we've cross-multiplied x or y or variable to get it squared. This one we won't. So instead, when we cross-multiply here, we need to make sure we put that whole number on the outside and the x plus 9 on the in so we can see the distribution. And then we multiply 15 times 15 to get 225. Walking through that, solving because we have the distribution, 9 times x gives us 9x. 9 times a positive 9 gives us a positive 81. And then we can subtract that 81. This is the only one that's working all the way out. I won't bother pausing. We end up with 9x equals 144. We divide by 9, finding that x is going to be 16. I have other geometric videos out there. I will go ahead and let you know. Majority of them are going to be these exact same problems. But you can go ahead, and I did also forget to put a little part right there. Go ahead and check them out anyway.